All right, we need to do section 3.3 next. Let's get my video started instead of looking at my happy mug. There we go. All right, this is section 3.3. It begins on page 187, and it's simplifying algebraic expressions. All right, we're going to simplify algebraic expressions. So begins on page 187. It reminds you about the commutative and associative property. You can add or multiply in any order. So we want to take advantage of that when we simplify these expressions. Example 1 in the middle of page 187 says simplify 2 open paren 3x close paren. So what this means is just 2 times 3x. Well, 2 times 3x is 6x, isn't it? If you had 3x's, right? If you had two 3x's, you'd have a 3x plus a 3x, you would have a 6x. Or if you had we have an x times an x, or excuse me, an x plus an x plus an x. If we had 2 of those, we'd have another x plus an x plus an x. We'd have a total of 6 x's. So you're just simplifying it by applying what you can, the computation. So 2 times 3x is 6x. So you'll practice doing a few of those. Not too bad. And then we move on to example 2 on page 188, and we pull some negatives into it. We have open paren, negative 3t close paren, open paren, negative 5. So open paren, negative 3t close paren, open paren, negative 5. That just means negative 3t times negative 5. So what is negative 3 times negative 5? Positive 15. And so we have positive 15t. We can multiply the 3 times the 5 because we can multiply in any order. And then we're left with multiplying times the t to get positive 15t. So we're simplifying these expressions. It's much easier to look at 15t than negative 3t times negative 5. Example 3 shows you what happens when there's more than one variable. If we have negative 3x, so open paren, negative 3x close paren, open paren, negative 2y close paren, we can multiply the negative 3 and the negative 2 and we get a positive 6, and then we multiply the x and the y and we just have to say x, y together, x times y. We don't know what they are because we don't know their values, so this is as far as we can go by saying it's 6xy. All right? Okay. Now, it reminds you on page 189 that you can speed things up. You can combine numbers that are friendly to multiply different numbers, to multiply and get your product. So you can bounce around and multiply things in any order, whatever kind of feels comfortable in your head doing your mental math. That's all it reminds you of at the top of page 189. Then we do another example in the middle of page 189 where we simplify 3 terms that are being multiplied with each other. So open paren, 2a close paren, open paren, 3b close paren, and open paren, 4c close paren. Hold on one moment. I'm going to upload another video in the midst of this one so that I can do more than one thing here. While it does that, it saves me some time if I can find it. CAP045. All right, that's uploading now while I continue to talk to you. All right, so open paren 2a close paren, open paren 3b close paren, open paren 4c. It just says 2a times 3b times 4c. So we can multiply 2 times 3 is 6, 6 times 4 is 24. You see how I did that? 2 times 3 is 6, 6 times 4 is 24. And then a times b times c, that's just going to be a, b, c right next to each other. When you put variables next to each other, it just means multiplication. So this simplifies to 24 abc. All right, you multiply your numbers together, 2 times 3 times 4, and then abc. We don't know what a, b, and c are, so we just write it 24 abc. All right. Then it discusses at the bottom of page 189 the distributive property. We worked on this before. Now we're going to work on it with variables. So if we have, as on 190, there's an example of 3 open paren, 4x plus 5, close paren. So recall the distributive property says that if we have a number outside of a paren, it is multiplying everything on the inside of the parentheses. So 3 open paren 4x plus 5 means 3 times 4x, which is 12x, plus 3 times 5, which is 15. So you rewrite it 12x plus 15. So that's what you'll do with examples like that. It works for the same way with subtraction. It doesn't matter if there's subtraction in our paren. So at the very bottom of page 190, it has 5 open paren 3x minus 2 close paren. 5 open paren 3x minus 2 close paren. So we do 5 times 3x and 5 times 2, and we keep that minus in between them. So 5 times 3x is 15x. 5 times a minus 2 is a minus 10, isn't it? 5 times negative 2 is negative 10, or 5 times 2 is 10, and pull the minus down. So this distributes to 15x minus 10. The example on the top of page 191 has us removing the parentheses. So that just means distribute when it says to remove the parentheses. It's another way of saying use the distributive property. So little letter A has negative 9 open paren 2t plus 7. So we're going to do negative 9 times 2t, that's negative 18t, and negative 9 times 7, that would be a negative 63, wouldn't it? So it would look like negative 18t minus 63. Little letter B has negative 5 open paren 4 minus 3y. So we're going to distribute negative 5 to 4 and have negative 20, and negative 5 to negative 3y. Remember, we look at this as a negative 3y. Well, negative 5 times a negative 3 is positive 15, and we carry down the y. So we get negative 20 plus 15y. You can go over that example on page 191. It talks about you can multiply quicker. You know, you can use all the shortcuts you want. You can extend the distributive property. So turn the page on to page 192 at the bottom, example 8. It has negative 5 open paren 2x minus 3y plus 8. Negative 5 open paren 2x minus 3y plus 8. And that means that we can distribute that negative 5 to every term inside the parentheses. We have to, because it's a negative 5 times the quantity of 2x minus 3y plus 8. So we got to distribute to all of them. Distributive property applies to every term. So negative 5 times 2x is a negative 10x. Negative 5 times a negative 3y. That's why I liked you to start looking, my thugs, you start looking at these as terms, and it really helps you out. Negative 5 times negative 3y is a positive 15y, and then negative 5 times a positive 8 is a negative 40. So see how you're applying your positive and negative rules quite often in this section, which is really great because you just finished learning them and now you're using them. So you can do the distributive property to more than one term. You do it to all the terms that are going on inside the parentheses. So example on page 193 extends it even further, and you've got 4 terms. So notice example 9 says negative 4 open paren negative 3a plus 4b minus 5c plus 12. So you're just going to distribute that negative 4 times the negative 3a, negative 4 times 4b, negative 4 times negative 5c, and negative 4 times 12. So negative 4 times negative 3a is 12a, positive 12a, right? Negative times negative. Negative 4 times positive 4 is going to be a negative 16b, isn't it? Negative 4 times positive 4 is negative 16b. Negative 4 times negative 5c is positive 20c. And negative 4 times positive 12 is negative 48. Do you see all that? You're just very careful about reminding yourself negative times negative is positive, negative times positive is negative, negative times negative is positive, and negative times positive negative. See how it's practicing all those positive and negative rules of multiplication. All right, now the next section is really, really important to understand that you need to distribute a negative. So right below the example we just did on page 193, it talks about multiplying by -1. So if you have -1 multiplying itself times an a, you actually have -a. There's a -1 sitting next to it. If it says -a, it's actually -1a. So you can think about that. Some students, sometimes they write a little kind of ghost 1 next to their a to remind themselves it's a -1. If you need to do that at first to really remind yourself that's what's happening, that's a really good trick to use. So the reason why this is important is in example 10, it shows you negative open paren a plus b. Well, what that means is actually there is a -1 sitting outside of that a plus b. So that -1 is applying itself to everything on the inside of a plus b. It's saying, give me the opposite of a plus b, isn't it? So that would be -a minus b. That's the opposite. -1 times a is -a. -1 times b is a -b. The opposite of open paren a plus b is -a minus b. All right, so apply that negative, distribute that negative to everything on the inside of the parens. You got to remember to do that. Super important. Gets people in trouble when they forget to do that. So turn to 11, example 11 on page 194, and now we have a negative open paren a minus b. So that's the same as saying -1 open paren a minus b. Apply that -1, distribute that -1 to the a, it becomes -a. Distribute the -1 to the -b, and it becomes positive b. So it's saying the opposite of -a minus b. Well, the opposite of a is -a. The opposite of -b is positive b. So we end up with -a plus b. Put a 1 on the outside if you need to. Distribute it. Watch what it's doing. That's what they do in the book. They show you that it is distributing. All right. Now example 12 shows that it applies to more than one term. So if you have a negative open paren 5 minus 7u plus 3t close paren, the negative applies itself to everything on the inside of the parentheses. Put a -1 on the outside and remind yourself that it's a -1. So -1 times positive 5 is -5. -1 times a -7u is positive 7u. -1 times positive 3t is minus 3t. Notice they all change to their opposites. That's what negative means, the opposite of, right? So we rewrite it -5 plus 7u minus 3t. So you will practice using your distributive property in this section. And then you'll be all done with 3.1, 3.2, and 3.3 and ready to return to class, next class. And in class, we will discuss these, do a little practice, and then we'll move on to 3.4 and 3.5, and a chapter is done. Have a good weekend. We'll see you next class.